So, hello, this talk is called Relativity Principle is Wrong, Part 1. And I gave this talk recently for CMPS, it's the John Chappell Natural Philosophy Society. So I split it into two parts, and this part I'm dealing with now is part 1, and I'll deal with part 2 in another video. Part 2 goes into more detail from a different direction and basing it more on a historical perspective. So picking up from previous talks, experiments that can be interpreted from Einstein's special relativity are supposed to be interpretable from Lorentz ether theory. Now in special relativity it's usually supposed to be that from the relativity principle there is no ether frame, and that's in conflict with the Lorentz theory. So Lorentz theory wants the relativity principle amended, i.e. Special relativity principle was wrong and need to replace it by another relativity principle that it explicitly emits as an ether, because at the moment the relativity principle from special relativity is usually interpreted as there's no ether. So that needs amending. You need to have it written up saying that there's explicitly an ether. So as per previous talks, I rely heavily now on artificial intelligence with my preferred AI as ChatGPT. And the reasons for this are, if you sort of like consider the question, if we want to investigate issues not covered by special relativity literature, where else can you go to? Question mark. I choose AI because it seems to collect the relevant information. AI collects the information out there on the internet and attempts to put it into a coherent form, even if sometimes fails to get it coherent. And I choose ChatGPT because it seems prepared to consider the existing point of view from the mainstream as being wrong. It then allows collecting of information into a form opposing that mainstream point of view. So ChatGPT tells me the following is Einstein's statement of the relativity principle when he first gives it in 1905 in his first paper on special relativity. He formulated the principle of relativity as follows. The laws by which the states of physical systems undergo change are not affected, whether these changes of state be referred to one or the other of two systems of coordinates in uniform translatory motion. And AI wants to give this in plain words. All physical laws are the same in any inertial frame. No experiment in uniform motion can reveal whether you are moving or at rest. Einstein then paired this with the second postulate: the speed of light in vacuum is the same in all inertial frames, independent of the motion of the source or observer. And AI then tells me what's wrong with this. So I ask the question, what's wrong with Einstein's statement? And AI replies as follows. Einstein's principle has three key problems. First one is the hidden assumption of all laws. He assumed all physical laws are the same in all inertial frames, but historically this only became clear after reinterpreting electromagnetism, which is Maxwell's equations for Newtonian gravity or quantum mechanics. It's not so straightforward. Number two, inertial frames only. The statement of saying inertial frames excludes accelerating or rotating frames, which are physical too. For example, in GPS or rotating systems, Sanak effect, the principle in its strict form does not apply without corrections. You've got to modify the principle if you want to suddenly start dealing with frames other than inertial frames. So I state it in my words, when Einstein says all laws, it's ambiguous what is meant by the laws. And when you're talking about inertial frames, okay, we talk about that, but what about the other types of frames? So it's ambiguous about what you're supposed to do with the other frames. And number 3 is the dependence on Lorentz symmetry. Einstein brought in Lorentz invariance by making the speed of light invariant, and that's the speed of light in vacuum. And it's probably just in the context of inertial frames, but that is ambiguous again. But this is not a principle derivable from the experiment alone. It is a strong postulate that effectively chooses the Lorentz group as the symmetry group of space-time. Later development, general relativity, quantum field theory, and so forth, show this principle is not the ultimate one. So ChatGPT gives the what he considers a correction, and so the corrected relativity principle is given is the form of fundamental physical laws is invariant under the symmetry group of space-time appropriate to the regime considered. And so it gives 3 different types of regime. You've got the non-relativistic mechanics of Galileo, Newton, and by non-relativistic it means non-Einstein's relativity. And so the variance under that is the Galilean group of transformations. And special relativity regime is the invariance under the Lorentz group, where the speed of light is constant for when it's light speed in vacuum. It's probably in the context of inertial frames only. Next is the general relativity. Einstein 1915 is the invariance under general coordinate transformations. And this ChatGPT points out this avoids Einstein's too strong 1905 claim that all the laws, and instead ties the principle to the deeper idea of space-time symmetry and variance. So the correction is trying to tidy up the mess Einstein made when he stated the principle of relativity. So ChatGPT summarizes it in short. Einstein 1905 is a statement all the laws of physics are the same in every inertial frame, and the correction is physical laws must respect the correct space-time symmetry, and that is the 3 types of regimes already mentioned, and that's depending on the regime of nature you are describing. So this is what I'm saying. So Einstein relativity principle is wrong and needs correcting, according to AI, that is. And from my experience with AI, it will just give the official mainstream physics point of view unless asked the correct questions pointing out problems with that official point of view. So this is what's come from me asking the right questions. So there are, of course, lots of directions I could then go in, but decided on the Lorentz theory versus the special relativity theory, and that led to an experiment to distinguish between the 2 theories. And so the issue I'm going to put aside for now is about the corrected special relativity principle versus the uncorrected one. Instead, I'm now going to go with the special relativity principle as is the way it's usually stated, and that's versus the amendment needed by the Lorentz theory. The usual interpretation of special relativity principle is that there's no ether, while Lorentz theory has ether. So Lorentz theory would want the relativity principle stated differently, thus have special relativity principle versus the Lorentzian relativity principle. So according to AI, there has been no experimental evidence to show a difference between these two relativity principles. So we have here is metaphysics, two different metaphysical principles with no physics to show any difference. But AI will later go on to propose an experiment which distinguishes these two principles. So the existing situation at the moment is you've got two different relativity principles, and you can't distinguish them by experiment because no experiment has been done to distinguish them. But that doesn't mean that in the future you could do an experiment to distinguish them. And so the question to AI is, would the relativity principle have to be amended for the Lorentz theory? And AI says yes, and then goes on to explain that. So ChatGPT AI tells me Einstein's relativity principle is that all the laws of physics are exactly the same in all inertial frames. There's no preferred frame. No experiment can reveal absolute motion, and that's usually what is said to be Einstein's relativity principle. If you look in the literature, things start to vary a bit, but that is generally what is said. So the amended relativity principle, which would be the Lorentzian friendly version, would be the outcomes of all feasible experiments performed with matter and light are the same in all inertial frames because physical systems are affected by motion relative to the ether in such a way that this invariance arises. This is weaker than Einstein's postulate. It preserves empirical equivalence across frames, meaning experiments, but it allows for a hidden absolute frame and absolute simultaneity. Next. So ChatGPT AI says empirically both predict the same results for almost all known experiments, so they're observationally indistinguishable. And so that's the situation at the moment. If you've got the Einstein relativity principle stated in the way that AI says, and the Lorentz relativity principle stated in the way AI says, then almost no known experiments can distinguish them. And I should have really picked up with AI and asked it, why did it say almost? Maybe there are some experiments, but I think the situation at the moment is that you can't distinguish between the two different principles by any known experiment that has been performed. So, but AI will eventually go on and propose an experiment that should be done to try to test the difference between these two principles. Anyway, conceptually, AI says Einstein's principle is stronger. You got universal invariance and no ether. Lorentzi's principle is weaker but compatible, where you got invariance only appears because of compensating effects while the ether exists. So you've got the two principles, one saying there's no ether and the other one saying there is an ether. And I think Einstein never really said that there's no ether. If you go back to his 1905 paper on special relativity, he's saying the ether is superfluous. And then the people who come after him have usually interpreted that to mean that there's no ether. But I wouldn't interpret superfluous to mean that. I would interpret there's still an ether. Anyway, that's the situation at the moment. Einstein is supposed to be saying there's no ether from his relativity principle. And so Lorentzi's theory is in conflict with that because it has an ether. AI goes on to say, philosophically, the choice depends on whether you value mathematical economy, which is Einstein, or metaphysical realism about time and space, which is Lorentz. And when I've complained about the physics education of students, I've complained that they haven't given them sufficient information on lots of things. So this is one of the issues here, that the students are not being pointed out the problem of Einstein theory versus Lorentz theory. So AI says, ChatGPT, if you take Lorentz theory seriously with a real ether and absolute time, then Einstein's strong version of the relativity principle is too strong. Einstein says the laws of physics are the same in all inertial frames. Period. Full stop, in other words. Lorentz would say the results of experiments are the same in all inertial frames because moving matter and clocks are physically altered by their motion through the ether. So Lorentz has an ether effect, and Einstein is saying there isn't one. So in Lorentz's view, ether exists, there is a true rest frame. And experiments are fooled because motion through the ether produces contractions, dilations and desynchronizations, that is, of clocks, that make all inertial frames look equivalent. Therefore, the relativity principle must be amended from a universal symmetry principle to an observational principle, a consequence of how nature disguises the ether. ChatGPT then goes on to talk about the Lorentzian framework with the ontology, which is the nature of things in that framework, as the ether exists with absolute time, t, and a preferred frame. Light, speed of light in vacuum is c in the ether frame, but not isotropic in moving frames. And the motion has effects of objects moving through the ether undergo length contraction along direction of motion, and clock retardation, slow ticking the clocks, and clock desynchronization. So symmetry is absolute but appears relative. So my question then to ChatGPT AI is, what extra effects are predicted by the Lorentz relativity principle? And the AI ChatGPT says the Lorentz relativity principle, interpreted in a neo-Lorentzian framework, predicts all the standard relativistic effects plus some subtle consequences that Einstein's principle either forbids or ignores. So it seems to be you've got extra things going on from the Lorentz relativity principle, which the Einstein relativity principle is not dealing with. And so ChatGPT proposes this experiment set up. And it's ChatGPT then describes what's going on. In the diagram it says, here's a conceptual blueprint for a next generation Lorentz ether detection experiment combining atomic interferometry and satellite-based clocks. This is designed to reveal absolute motion if Lorentzian effects exist. And so, number one, the experimental idea, the goal is to detect absolute velocity of the lab relative to a preferred frame, ether in other words, via one-way or directional effects that special relativity cannot explain. And the core principle, motion through the ether produces tiny, real physical effects, and that is phase shifts and matter waves, clock rate differences, all one way, light speed and anisotropy. And that would, okay, so hopefully that is clear. So ChatGPT AI explains the following. A setup of components is you got a satellite clock network, place high precision atomic clocks in several satellites in known orbits, include a ground-based reference clock, and you measure one-way signal travel times between clocks in different directions along and against Earth's motion relative to the cosmic microwave background. And the key idea is to use slow clock transport or inertial guidance to synchronize clocks independently of light signals. And for the terrestrial atomic interferometer, use a matter wave interferometer, atoms or molecules on the ground, where you split atomic wave packets along paths aligned with and against the Earth's motion relative to the cosmic microwave background. And then you detect phase differences between the two arms due to velocity dependent time or length effects predicted by Lorentz theory. So then next thing to do is the data analysis, and ChatGPT AI says compare measured travel times or phased shifts in different directions and at different times of day / year. Look for systematic directional dependence correlated with known Earth motion relative to the cosmic microwave background. Control for known special relativity effects, which is time dilation, gravitational redshift, and orbital motion, etc. So this is the mathematics that ChatGPT then gives for it, in where you get C is the, here written in the equation, is the normal thing you think of as the constant speed of light, but you've got the C subscript effective, which is the effective speed of light, and that speed changes, the effective speed of light changes. So ChatGPT points out the advantages, combines space-based long baselines and ultra-sensitive terrestrial measurements, maximizing sensitivity to directional effects, avoids reliance on Einstein's synchronization by independently transporting or referencing clocks, exploits known Earth motion relative to the cosmic microwave background as a guide to the expected ether direction. The challenges you face with it is you've got environmental noise from such things as temperature and vibrations, which you've got to overcome, and then its synchronization errors must be controlled at extremely high precision, and it requires careful subtraction of standard special relativity and general relativity effects to isolate possible Lorentzian signal. The bottom line for this is such an experiment could in principle reveal absolute motion if Lorentzi's ether exists. All current experiments will fail to detect it because either they measure round trip light only, which is in the Michelson-Morley type experiments, and that means light going in a round trip. Light goes from point A to a point B and then back to a point A again, and that's two-way light speed, round-way light trip. And next problem is clock synchronization assumes special relativity isotropy, and that's masking one-way effects. So one-way light speed, in other words, is going, if your light goes from point A to a point B, and that's one-way light speed, and that should be variable, which has been talked about in previous mathematics, is the effective light speed. And so that's what you're up against. So back to me now. If you've seen other talks by me, you often see me complaining about the mainstream moving the call pace, and that means they're moving what they're saying. One minute you catch them out saying one thing, and the next moment they move on and say something different and pretend that's what they were saying all the time. So I suspect they would try to use that same sort of tactic against what AI has said here. That tactic and other tactics. So that is the end of part 1. Thank you for your attention, and we continue on in next part 2.